It's as clear as day and night, but on an exotic alien world, astronomers have for the first time measured the temperatures varying across the surface of a planet beyond our solar system.
This is the hidden universe of the Spitzer Space Telescope, exploring the mysteries of infrared astronomy with your host, Dr. Robert Hurt.
Planets orbiting other sun-like stars are notoriously difficult to observe. They're so distant that no telescope is yet powerful enough to photograph them directly. Their feeble light is blurred into the glare of the stars they orbit. Nonetheless, since 1995, astronomers have discovered over 200 extrasolar planets by observing the effects they have on their parent stars. These include gravitationally induced wobbles and even faint dimmings of the starlight when the planets pass in front. The infrared eye of the Spitzer Space Telescope has already proven to be an exciting tool for learning more about these alien worlds. In 2005, astronomers Drake Deming and Dave Charbonneau announced the first detection of light from two extrasolar planets, seen as they went into eclipse behind their stars. Now, astronomers Joe Harrington of the University of Central Florida and Brad Hansen of UCLA have taken this one step further. They have actually measured differences between the day and night sides of such a world.
So this particular system, the star is called Upsilon Andromeda because it's in the constellation Andromeda, and this actually has three known planets orbiting it, named conventionally just B, C, and D. And this particular one we're looking for is a signal from Upsilon Andromeda B. So that's the closest planet. So this is a planet that's actually orbiting its parent star in about a 4.5 day orbital period. So it's much closer to its parent star than, say, any of the planets in our solar system are.
This planet isn't just an extra hot Mercury. It's a gas giant as massive as Jupiter, and while there's nothing like it in our own solar system, astronomers have found it's far from unique. Many so-called hot Jupiters have been discovered around other stars, but very little is yet known about what these roasting balls of gas are really like.
And so the natural question that came about was, how does this increased amount of energy that they're receiving from the sun affect the structure of the planet and its atmosphere? So some models suggest that in fact the light is absorbed and re-radiated very quickly so that the heat is coming out mostly on the day side rather than the night side, whereas other models suggest that maybe if there are very strong winds, such as give rise to the bands on Jupiter, then in fact the light can be distributed, the energy can be distributed quite evenly around the planet before it gets re-emitted.
To test these models, Harrington and Hansen needed to observe this system in the infrared, where the planet emits most of its light. Though the star is over 100 times brighter, Spitzer could still pick out the small variations in the combined brightness as the planet moved through its orbit.
So we went out, we tried to observe the system to see whether there was a day-night temperature difference, and we found in fact evidence that there is a strong day-night temperature difference between the day side and the night side, based on the fact that we see this characteristic variation in the total light from the system over the course of 4.5 days, and exactly in the right phase, in the right time to correspond to this model, where in fact the day side is hot and the night side is cold.
The temperature difference is immense, over 2,500 degrees Fahrenheit or 1,400 degrees Celsius between the comfortably cool night side and the broiling hot spot facing the star. This is vastly different from the infrared structure of Jupiter, which is even temperatured all around. This remarkable result marks the first time any kind of variation has been seen across the surface of a planet outside our solar system. For now, only imaginative artists can provide pictures of what they could look like. But until the day we can take real snapshots, astronomers will continue to find clever ways to explore this growing catalog of alien worlds.
The Hidden Universe is produced by the Spitzer Science Center at the California Institute of Technology in Pasadena. The Spitzer Space Telescope mission is managed by NASA's Jet Propulsion Laboratory.